Hi there. In this section, we're going to look at solving inequalities graphically. And in this slide, we're going to look at specifically how to solve inequalities involving absolute value. And we'll review how to solve equalities while we're at it. So the task here is to solve the following equations and inequalities graphically. And in part A, we're given the absolute value of 2x plus 3 equal to 5, okay, and asked to find the solution set. And in part B and C, we have absolute value of 2x plus 3 less than 5 and absolute value of 2x plus 3 greater than or equal to 5 in part C. So let's graph y equals absolute value of 2x plus 3 and also y equals 5. Okay, let's go and do that. Okay. So what did I say? We were going to graph y equals absolute value, and if you just type ABS, you'll get the absolute value of 2x plus 3, okay? And in Desmos, you don't even need to say y equals. It'll just do it for you. But if you're going to graph something like y equals 5, you do need to include that y equals there. So we see both of those things there, right? In green, we have the absolute value of 2x plus 3, and in purple, y equals 5, right? And if we want to know where those two are equal, all we need to do is find their intersection, right? The x values of where they intersect are the x values that make absolute value of 2x plus 3 equal to 5, okay, because the output is 5 for both of those. As I was saying, when we graph the absolute value of 2x plus 3, we get this green V-shaped graph, right? And we've graphed y equals 5, and we see that they intersect at the point negative 4, 5, and also 1, 5. So where they are equal are at the x value of those intersections. So the solution set is negative 4, and 1. All right, so now let's take a look at the inequality piece. So if we have absolute value of 2x plus 3 less than 5, what that means is we want all of the values of the graph of absolute value of 2x plus 3 that lie below the line y equal 5. That's really what we're asking. Okay, so let's highlight that region. So because we have a strictly less than, on these intersection points, I'm going to put open dots. I know they're closed on the graph, but try to think of those as being open dots. And I want everything below, right? So just shade the part of the absolute value of 2x plus 3 that lies below the line y equal 5. So that piece that I just shaded in red, what is the domain of it? Because that is really where absolute value of 2x plus 3 is less than 5, okay? Well, the domain of that piece is negative 4 to 1, right? And I'm going to state that in interval notation, negative 4 to 1, yes? Okay, and I'm using the open parentheses because we have strictly less than, so we're not including the point right there at x equal negative 4 or at x equal 1. Now let's look at absolute value of 2x plus 3 greater than or equal to 5. Okay, so now we want everything that is above the line y equal 5 and equal to it, right? Greater than or equal to. So I'm going to use a different color now. Here in blue, I'm going to just fill in those dots, okay? So if you can see that or not, I'm just filling in those dots at the intersection points. And then shade the part of absolute value of x plus 3 that is above, greater than, right? So we really have two intervals, right? Off here, less than negative 4 or greater than 1. Okay, so that part that I just shaded in blue, tell me what the domain of it is. Well, I'm going to have negative infinity to negative 4, and it's greater than or equal to, so I'm going to use close brackets, in union with 1 to positive infinity, again with a closed bracket at 1, and always put open brackets at an infinity. Okay, so hopefully you're getting the idea with that. Now, Desmos is really nice because you can actually enter a full inequality into it, and it will shade the region that you want. It's important to me that you understand graphically what's going on here, like the explanation that I just gave around why these things are the way they are. But let's take a look at some shortcut methods in Desmos. All right, so back here in Desmos, we see that before we entered both sides of the equation or inequality separately so that we could see them both graphed together. A trick that you can have, I'm going to just change this up a little bit. We'll get rid of the y equals 5, and we'll have absolute value of 2x plus 3 strictly less than 5. Okay, notice what happened there. When I just entered that, I'm not seeing the graph of either one here, but I am seeing the shaded region, and the shaded region is between what values? Between x equal -4 and x equal 1, right? Which is what we said it was going to be, between -4 and 1. So Desmos will give you the answer, but it's not very good at showing you why that is, right? So it's good to have a graphical understanding of that. Now, if we change this to being greater than or equal to, down on the keypad here, they have a greater than or equal to sign. You can use the, okay, there we go. And then it gives us the two extremes, right? So -infinity up to -4, and then 1 to positive infinity. And you notice here, the lines at -4 and at 1 are solid, right? Those vertical lines. Whereas if I just did a straight up greater than, they would be dashed, right? And before, when I had the less than sign, they were also dashed, right? When you're not including those values. So I just wanted to remind you that that feature is there in Desmos, but I also want you to understand what's actually happening graphically with this. Okay, great.